Hello, everyone. So it's a pleasure to be here. Um, so I'm not going to talk more about the fines, right? So that's the main part of the GDPR. I try to circulate around the idea of data science governance rather than only GDPR, and I'll come to accountability principles. And I will try to explain why it can be very good for your business as data scientist to think about GDPR as a tool rather than a hammer. So, um, so I've been told that there you go. So a few words about myself and Kensu, quickly. So I'm Andy Petrella. So I used to be the creator of the Spark notebook. I don't know if someone knows about it. So it's one of the notebooks around. I started years ago because I had to do some Scala things on Spark. It was back in 2012. I'm also giving a lot of training for O'Reilly, essentially data science pipeline using distributed technologies. But why I'm here talking about GDPR and data science governance is because we founded with Xavier Tordoir this company, Kensu, back in 2015 in Belgium, trying to provide a stack for data science, and we call it back then Agile Data Science Toolkit. But when we were processing and we were going to customers, we discovered that one piece of our software, which was the data science catalog, was very appealing to the people. So we only focus on that now, and we are building this data science governance tool. We've been accelerated in the US, in Belgium, and now we are actually incorporated in the US, which is pretty fantastic so far. Right, so the few topics that I will cover very quickly, there is this talk. I'll get back to some thoughts about data science. Also, what is data science governance? I don't know if many people know about data science governance. It's pretty dark, but if there is anybody that knows anything about data science governance, just raise your hand. Oh, a few, right, that's good. So what are the accountability principles and transparency principles? Is there anybody really, into GDPR that know what are those two things, for instance? Raise your hands, maybe. Okay, so good percentage, good. I don't have to go into details there. It's the wrong version of my deck. The fifth part is really not about Spark anymore, but more about the consequences for the business instead. So some thoughts on data science. I'm not going to go into details because actually you are a very good audience for that. So machine learning, long story short, it started in 50s, right? So everybody knows that. There is an AI winter in 70s for many reasons. It got back because we discovered the backpropagation. But what's very interesting is that from the 90s, it has been integrated into softwares. We started making money out of these mathematical and computer concepts until really recently, 2010. Where machine learning, AI, we had several words for the same thing, like in 5 years, but essentially it's machine learning, AI. Everything is packaged up into AI now. It has a good exposure, a lot of money is invested, so it's the right time now to think about, okay, how to make it kind of enterprise ready somehow. So you have many tools now popping up, proposing tools and also product for enterprise readiness. But data science essentially is not only math for me, of course. It adds at least engineering, right? If you remember, D.G. Patel, who used to be the CDO of the US, United States, claimed data scientist, so he coined the name in 2008. And it coincides with the time where machine learning was included into softwares and sold to companies, kind of, right? So it's pretty much where engineering was added to the mix, not only math and models. And now, with distributed computing, or not really big data, but really distributed computing, more and more engineering has to be included into these softwares. But of course, it wouldn't be anything without experimentation. So experimentation is there for forever, but now we have so much data available, of course. Many tools, every 2 months you would have a new tool, new library, new framework. So many things you can try, of course. So we have all these things. So why would you, only choose one and stick with it? So you can try other. It might be more performant, might be more accurate. Also, new discoveries are made, so you want to test these new things. But now that we have distributed computing, it's kind of commodity now that you have an Hadoop cluster, a Spark cluster, or whatsoever. So you want to try everything. That's something that you would like. And you have product like Data Robot who is helping you in doing that, right? So running thousands of models in a bunch of time. But as data scientists, you want to add some creativity to your projects, and you want to try many, many things in order to discover new insights, of course, but also to be more into the data. So a recap. Data science for me, at least, so it's in my own perception, is math, engineering, and creativity. So if you think now of data science, the way I think about it is like an umbrella on top of many, many things. And essentially, everything in which is an activity onto data, something that uses data, is part of the data science projects that you have to work in. Right? So pretty much everybody can be a data scientist, or at least work with a data scientist somehow. It's not like business intelligence in a different team who has some data and works on his own. No, actually now we have teams and we have to collaborate. And then it becomes, activities on data rather than, you do ETL, I do machine learning. All right. If you don't believe me, there is this excellent paper from Google on NIPS. So they have this fancy image there. You have everything, and you have ML code in dark box there in the middle. That doesn't mean that it's not important. That means that it's surrounded by so many things around it. And all the boxes, grayish, they can fail. They can fail. The ML code can fail, but everything around can fail as well. Right? That's something that we have in mind. This paper is Hidden Technical Depth in Machine Learning System. And that's one of the most important pictures I saw in this paper. So really highly recommended to read this paper, 7 pages, I think. So check it out. So now data science governance, what it can be. Let's get back to data pipelines very quickly. Data pipeline is connecting activities, essentially. So you have data in the middle, and in between you have activities, you have tools, you have libraries, you have people working on different service data science tool or projects. And actually, pipelines is nothing but just that. And actually, most of the time we think about a pipeline like, okay, it's an end-to-end thing. So we take data on one point and we do something at the end. But actually, in order to be more efficient, right, or to share your work, then you will cut and wire and rewire these pipelines. So you will say, okay, I already computed this feature extraction. I already did this dimension reduction, right? So just use my data instead of redoing it, right? I know how to restructure this data, so just use this database or this file, right? So actually, these pipelines are now cut and wired rather than thought as end-to-end pipelines. So that means also that the interdependency between data is very important, and it's growing with the new initiative that you have. Every time you want to do something new in an enterprise, you will try to see, okay, where are the data? And you think the data is a data in its own, but actually it has an history. Not on its own again, but in the enterprise, it has been, it's a result of another process, for instance. All right, so we don't do data pipelines for the sake of it. Of course, we want to take decisions, right? That makes sense, right? So otherwise, we wouldn't compute anything on the data. We just want to make sure that we can take decisions, actionable data, the way we call it. And the thing is that decisions are generally taken by humans, or humans are responsible of the decision that has been taken by some tool. But given that the pipelines are cut and wired, right? Actually, as a data scientist, I used to be very anxious about what I deployed, because it's highly probable that something around my system can fail or something can change, right? So when I'm deploying something, in medical or geospatial troops, defense department or whatsoever, actually you have lives in your hands. So you can really be anxious about it. And the source of anxiety are a few of them. Data are used, so you use some data and suddenly the pattern are changing in production, right? And you're not notified, it's just changing. There is a social economical event that happened and then the patterns are changing, so that's something that can change, of course, your model. It can be robust, but it might not be robust against all the different changes that can happen on the patterns. And one of the tools upstream is changed. Someone just changed a Python script, it just deployed a new one, and then the data changed, so you update the data, and then actually your model is also impacted. Others, like the most important one is probably when your insights are deviating for the truth, right? It's pretty hard to detect, of course, but at least if you have enough characteristic which is describing accuracy, then you can start, being aware of this kind of distance that you take from the reality. So at some point, if you're anxious, developers, what they do when they're anxious, they do tests, right? So they used to do tests in order to ensure that when they deploy something, they say, okay, it passes all the unit, all the functional, all the integration tests, so it should be okay, right? And if there are some problems, anyways, I put some logs, I put some debug information into my project so I can get some feedback if something goes wrong into production. However, what happens if our project is actually degrading in accuracy or performance because the data has changed? So what can we do about this? We cannot really generate all the data, right? So it would be cumbersome and useless probably. So how can we actually debug a data science pipeline, a whole bunch of different activities without having the big picture? And most of the time, when the model is deployed in production and someone sees that it's deviating from the truth, then you ask for the production data, and the answer is striking: no, you won't have it. Or it will take some time. So debugging in data science is pretty hard. So that's where data science governance enters into the mix. So let's think about data governance. Controls that data meets precise standards and involves monitoring against production data. Production data is the most important part here. But you want to ensure that it meets precise standards and quality, of course. If you think about data science governance, provided data science can be activity, so you want to control that data activity meets precise standards involving monitoring against production data activity. So that activity is not data, it's more a project or a tool, right? So if you think about data activity, it's not only the tool per se, it's also the infrastructure, the data, of course, the users that use the data, the systems around it, and the different processings that you had done, and also the goal that you pursued, of course. If you think about data quality, actually data quality is interesting, but also if your model is robust, right, you might not pay attention to the quality of the data. If it's robust, you will pay attention to the data when your model is going down. You might not, change your system in production because you want to clean more the data if your model is still robust, so you might not want to change it. So this is why you want to have everything in control so that you know when you have to make some changes. So essentially, governing data science means that you want to know exactly what happens on the data, where, when, how, for what reason, and also if you change something, that's most probably the ultimate goal that you want to reach in governance, is that if you change something, what happens? If I change this, and you run a PCA, you choose a certain threshold of information that you want to keep, and at some point you change it, right? Because you want to have more information. It may have impact. It may have some impact on other systems because your data set, which is taking maybe hours to compute, might be used by someone else that you didn't even know, because it's stored in the data lake, right? It's available, right? It can be discovered using a data catalog, so it can be used, but you don't know it, right? So you change your model, you change your script, it changes the metadata, and it might impact the performance. It might not be, the accuracy of the model, of course, because you are adding some variations. So it might be more accurate, of course, or it will start, of course, overperform. But the thing is that it might be less performant in times. It might take more time to compute because you may have more data, for instance. And if it's a streaming application, then it has a big impact, probably. Think about trading system, for instance. So, yeah, sorry. The other one that I like is, if my slide wants to get back, is how to track tracking the performances, the metrics that is qualifying some activity, qualifying the quality of some processing. So we switch from data quality to process quality, for instance. I'm very bad at that, and apparently, sorry, okay. There, it works. So if you reach that level of information about the activities, it starts to become a kind of continuous integration tool for data science. You continuously integrate your work with the work of the others, right? And you ensure that it's still reaching the right standards in accuracy and performances. That's the kind of things that we would love to have generally as data scientists, deploy something, and at some point having something that tells me if it's going down. And if it goes down, you want to be able to know if it's the tool that you have used which is going down, or it's less accurate. The data has changed, a process has changed, or a system has changed. Think about Docker. I like this one because it's not intuitive as a problem for data science. You think about Docker, you use some tool which are doing, some tools that are doing some estimations, right? And to do the estimation within a certain time, they are using the resources of the machine. And it depends on how many CPUs or memory you may have. So if you change the deployment of your Docker and you allow less resources for your script, and the people who are deploying your script are not aware that changing the number of CPUs, even if they're not used all the time at 95%, okay, can impact the quality of the data that you produce, right? That's something interesting because apparently it's not very harmful to change from 2 gigs to 1 gig or from 4 CPU to 3 CPU, but it can have very hard impact. Essentially in big data or distributed computing, when you want to have estimations in different machines after deployment, and you have to configure all the executors. But when you have this kind of information in your hands, then you have also the control on the production, right? So you don't have the data, but at least you have all the patterns. You have the patterns of the data in the past. So think about that one. So if you have a process which is, let's say, a Python script or a JavaScript, it's issuing a SQL query to a database, okay? So what you want to know is how many rows, for instance, is returned by this query. You don't want to know how many rows there is in a database, because otherwise, when you want to debug your stuff, you have to issue the query again, and reducing the amount of data back to the state where it was like 2 weeks ago, right? You want to know how many rows and what are the descriptive statistics of the data that you received as well back then. And you want to have this time series, because actually this time series is kind of proxy against the data. It's a kind of proxy. You have the timeline of how the data evolves based on your query. It's like a Bayesian network, something. So with this kind of information, I didn't talk about technologies, right? The intent of this kind of governance is to be totally independent of technologies, so that at some point, if you want to change the technology, right, so the information shouldn't change. So you can debug your stuff independently of the technologies. You don't have to know the technology behind the process in order to debug it, for instance, because we are talking about data, we're talking about performances. And of course, when you have this kind of problems that you want to solve, then you can also be aware of who has the right knowledge in order to help you in debugging the data which has changed, upstream in the pipeline, and you don't know how it works. How, that's the hard part, of course, because it's not that easy. The challenges are that many tools, many data, it's changing every day. The number of processing is growing, of course, because we have this kind of data labs, we have this data science involvement in different enterprise, we have this AI project starting in different enterprise, so this kind of activity is growing. So how can we control this amount of information? And of course, we have to take care as well. We have to take care as well of the legacy, of course, because the legacy. Think about the COBOL stuff and the DB2 stuff, right? This is where the data comes into enterprise, and then they are extracted, and then after you use them, so you are entirely relying on the accuracy of this database. So how do we take care of the legacy then? Did it switch? All right. So first of all, we need to get the data. So I only have 5 minutes, so I'm going to speed up a little bit. So we need to get the data. So essentially, it's a tough work, but not as much as data governance. You have to connect to all the different activities, connect metadata. And when I say metadata, is more about metadata about the system around it, the lineage, the statistics of the data that you have consumed, accuracy measures, and so on. It doesn't mean that you have to collect this kind of activity every time there is a query, for instance, but at least you can batch them. Then you have to connect the data, of course, because you have received data from everywhere. Data pipelines are not created in beautiful wireframe every time, so you need at some point to reconnect them into another tool, and that's where the fun part starts. So you can have all this information and start matching them. Afterwards, when you have the data, finally you can use them, right? Using the data, in this case, you have a kind of large network of information connecting different kind of infrastructure, systems, tools, data, and whatsoever. This is where you will start to have fun as data scientists, because you have a kind of metadata repository that you will be able to use in order to optimize your own stuff or to provide recommendation to other people, like about, you do Untitled, we did that 2 years ago, we used that tool, maybe you should use it. Or, oh, you already used that tool, but maybe you can use this data instead. And it's independently of the tool and the people, of course. So you can start doing this across the whole enterprise. But the one that I like pretty much is the impact analysis. So I have only 4 minutes for the GDPR, so we'll switch to that one. General data protection regulation, I guess that if you're here, you know what it's all about. So the accountability principle, in 2 words, is you need to know what you do with the data, right? So if you do something with the data, you need to be able to explain to people what you have done with it, from where the data was coming from, where it goes. So actually, you have to audit internal processes activities. Transparency, you need to be able to say exactly what you have done, right? So if you run a model, you need to be able to explain what happened in the model and how the results can be used. So where data science governance comes into the party is actually because if you do data science governance, you are collecting so many information, right, that GDPR becomes only a facet onto this data, right? Based on the collection of the connection of the activities, you can directly create what's named the process register, which is a list of all the activities happening on the data with some business goals, right, from the start to the end, right? Based on the connection of the data, you can extract that and you can present it. Transparency, because it's a data science governance, of course, you will also collect metadata about the data science facts behind it. So you will be able to say, okay, this model is a deep learning model. This model is a regression. This model is this model with this optimization algorithms and so on and so forth. So you can collect this kind of metadata so that you can do 2 things at least. You can explain to the people the different parameters that has been trained, or you can say, actually, it's a deep learning, so you cannot really use deep learning in the context of GDPR if you want to do some scoring for insurance policy, for instance. So you can do 2 things with this kind of information, and you can reach a good level of compliance for GDPR in that. The consequences for the business. So a few one-liners. Data to business. So if you think about KPIs, so this is how we estimate the quality of a business. So we have KPIs, but what are KPIs if not data, right? So the better KPIs, the more accurate the KPIs are, the better you will be able to drive your business normally. And how to ensure that the KPIs are good is because you know that your pipeline is respecting certain level of standards and accuracy. The other way around, business to data, actually you want to change the business to match the data. This is how we think about business intelligence. I like to say, what if we can change the business to adapt the data? So if you want to see patterns in the data, what can we do at the business level to change the patterns? This is what is named disruption, right? So if you want to disrupt, you need to change how the people are reacting to your stuff and not matching to how they think right now. So that's why I think that GDPR can have a very good impact on the business. It can be fun for data scientists. This is why I'm here. It can be really fun for data scientists to use GDPR as a tool and not as a stick to beat you or a source of anxiety. In Kansu, very quickly, so we need to take this idea further. So just to show this this chart, if you want to show up. So what do we do? I definitely doesn't want to, right? There is an image, maybe it takes time to load. Or it's 25 seconds, maybe it doesn't want to. So I explained what, how, and why we want to do data science. This is how we do it, right? So we have a tool which is essentially an API that is able to collect information, where we connect the information and learn from it. And the only thing that has to be done is to create the binders to collect the metadata about the activities, and then we can send back to the user some cookies, like, okay, here is some information about your process, here is some recommendation or whatsoever. So this is how it's done, but again, it's not by looking at the data, but looking at how we consume the data instead. So of course we have a module for GDPR. That's why also I'm here, which is very interesting for the DPO, the data protection officer, where we just extract information from the graph that we have, and we present it in a manner which is intelligible for them, and also we are able to create alerts for the people, like, okay, hey, you should check this or check that. So thanks for listening to me. It was a pleasure to be here again. Thanks, Ruben, for inviting me, and if there is any question, I'm still there.